Alright, the stream has started. Let me check it whether it is working or not. Okay, it is working. Alright, now we're gonna start this live streaming now. If you have any questions, guys, feel free to ask here. And do you have any question? If you have any question, ask your question right here. In this video, we're going to solve this coding interview question, longest consecutive sequence. Given an unsorted array, integers, nums, given an unsorted integers nums. So we're given an array of integers nums, return the length of the longest consecutive element sequence, and we have a constraint. Our algorithm should run in linear time complexity. For examples, we have here this array of integers. What is the longest consecutive subsequence? What is a consecutive? Consecutive means one greater than the previous one. So if we start from here 1, then what is the next? 2 exists. What is the next of 2? 3. What is the next of 3? 4. So we have here total 4. We have the longest consecutive element sequence of 4. 1, 2, 3, 4. For this given array, if we start from 0, if we add 1 to 0, we get 1. If we add 1 to this one, we get 2, 3, then 4, 5, 6, 7, 8. So here we have total 9. We can see the length of longest consecutive sequence is 9. So we have to solve this problem. Now let's see how to solve this problem. Longest consecutive subsequence. All right. Now, for examples, this is your problem. Okay, longest consecutive subsequence given an unsorted array of integers nums. Return the length of the longest consecutive element sequence. All right. Here we have these two examples. In here, if we start from 1, what is the longest consecutive subsequence? If we add 1 to this one, we get 2 exists. If we add 1 to this 2, 3 exists. If we add 1 to this 3, 4 exists. So this is the longest consecutive subsequence, or sequence we can say. And here, if we add 1 to this 4, 5 does not exist. So this is the longest. Also here we have 2, 3, 4. This is not the longest. Here also we have just we can say 3, 4 or 2, 3. But the longest consecutive sequence or subsequence is this 1, 2, 3, 4. And here in this array of integers, what is the longest increasing subsequence? If we start from 0, if we add 1 exists, 2 exists, 3 exists, 4, 5, 6, 7, 8, 9. So the consequences, sorry, here we should have 8. The consequence, here the consecutive means one greater than the previous one, one greater than the previous one. Okay? Hope you've understood this problem statement. Now, let's see how to solve this problem. First thing, what we can do, we can just sort the array. If we just sort the array, we'll get 1, 2, 3, 4, 100, and 200. By sorting this array, we can solve this problem by scanning ones from left to right. So the overall time complexity would be for a sorting approach O of n log n. The sorting algorithm will take O of n log n, and the time complexity for our linear scan will be O of n. And the space complexity would be O of 1 actually. The sorting algorithms will take of in as space complexity, but we're not considering that. So here it will take of 1 space complexity. This is not efficient. If we came up with this solution in an interview settings, the interviewer will not be happy with this solution. You have to optimize it. Now let's see how to solve this problem efficiently without sorting in linear time complexity. First thing, what we have to do, we have to create a set data structure. Now first we're going to add all the element to a set data structure. Let's assume this is our set, or you can say hash set. Let's add here 100, then 4, 200. We're adding here in this set data structure. That's because we can access the element. We can check in constant time whether certain element exists or not. So we have constructed our set. Now we're going to iterate this array from left to right. From left to right. The first element here is 100. Now we're going to check. Does the previous element of 100, what is the previous of 100? 99. Does 99 exist? Just 99 exist? No. Since it does not exist, we're going to find out our current streak. So let's say your current streak initially, our current streak equals to 1 because we have only one element here, and our current number equals to this number 100. Now we're going to check, does 101 exist? No, 101 does not exist. So we'll do nothing and we'll just update in our answer. We'll have an answer variable. In our answer, we'll store the length. So let's call it len. We can say len. Len equals to, initially we had 0, now we're going to update it with 1. Now let's move forward. 4. Does the previous element of 4 exist? Yes. We can look up in this hash set. By just finding out the previous element. Previous element exists. So we don't have to worry about this 4. When we raise 3, we'll calculate that. Because if we start now, we will not get the largest or the longest sequence, as longest consecutive sequence. So we'll not start from 4 since 3 exists. So including 4, if we start at this 4, if we include 4 as the first element, then we will not have the longest consecutive sequence. Let's move to now this guy, 200. 200, the previous one is 199. Does it exist in our hash set? No, it does not exist. So our current streak is 1 and our current number is 200. Now let's add 1 to this because we have to find out the consecutive value. So if we add here, we'll get 201. It does not exist. So we have here length equals to 1. I will not update it. Now let's move forward. Now we have 1. Does the previous element of 1, what is the previous consecutive of 1? That is 0. Does 0 exist? No. Since 0 does not exist, so we can start from 1. This sequence can start from 1. So here our current number equals to 1. What is the next? 2. Does 2 exist? Yes, 2 exists. 2 exists in our hash set. We can look up in constant time. And here let's now let's add 1 to 2. We have 3. Does 3 exist? Yes, exist. So let's add here. And our current streak will be increased. At this point, it will be 3. At every step, we have to increase current streak. And then let's add 1 to 4. 1 to 3 will get 4. Does 4 exist? Yes, 4 exists. So this is our sequence. And here, let's update this length here. And let's add 5. Does 5 exist? No, 5 does not exist. So we're done. We have the length, a current streak is 4. We'll take the maximum. Maximum of 4 and 1 is 4. So let's update this value with 4. Okay, so we are done. At this point we're done. Now here current num equals to we will have no value. We will use this inside. We will say that when we'll implement the algorithm. Now let's move forward. Does the previous of 3 exist? Yes, 2 exist. 2 exist. So we cannot start at 3 because if we start at 3, we will not have the longest consecutive sequence. So we will not start here. Let's move forward. 2. What is the left or the previous of 2? 1. Does 1 exist? Yes, it exists. So we cannot start at 2 because if we include 2 as the first element, this will not be the longest. So we will not do that. Let's move forward. We are done. So we have finished processing this array. At the end, we find out 4. We'll return this 4. This is how we can solve this question. And the time complexity of this algorithm is actually of O of n, and the space complexity is also O of n, because we are storing every single element in our set data structure. For the worst case, we will have n number of elements in our set, and here we have this n. Now you might be worrying about this time complexity. Just remember it that for every element, for one element, we'll for the worst case, we will traverse the entire array for one element. Okay, we will traverse the array entire array 1. So if we have input like this 1 2 3 4 0, at the first element we have 0. Okay, the previous is -1, does not exist, so we will start here. Then we will check this, we will check this, we will check this, we will check this. We will have our current stick 5. And here then we will move here, the previous exists, so we will not do that. Previous one exists, we will not process that. Again here on the left we have 2, we will not process it because previous exists. And here for 4 we have 3 exists, so we will not do that. So for the worst case, we will traverse this array 12 times. We will traverse in 12 times for worst cases. So this algorithm will takes basically linear time complexity. We can just ignore the constant part, so it takes a linear time complexity. Hope you understood this explanation. For a better understanding, let's take another example. For sake of understanding, let's assume that we're given this array. First, let's create a set data structure so we can access in constant time. So let's insert every single element in our set data structure. 5 8 4 6 and 0 1. Okay, now we will have our answer, or length equals to initially 0, length of our longest consecutive sequence. And we will have our current streak. We will have current streak and for our current number. Okay, we'll see it. Now we have here 0. What is the previous element of 0? -1. Does -1 exist in this array? No, does not exist. So we can place this 0 as the first element of our sequence. That's it. If the previous of 0 does not exist, we will just start it. We'll just start our sequence from 0. No problem, we can pick it as the first element. So now here in 0, so our current streak is 1, since 0 is our first element here, and current num, our current num equals to our current number 0. Okay, now let's add 1 to 0. So if we add 1, what we will get? We get 1. So does 1 exist in our set? Yes, it exists. So let's increase our current streak to 2. Now let's add it to 2. Here let's add 1, so we get 2. Does 2 exist in our set? Yes, exist. So let's increase our current streak to 3. Now our next element, if we add 1 to 2, we get 3. Does 3 exist? Yes, exist. So let's add here a 1, so we get 4. Then if we add 1 to 3, we get here 4. Does 4 exist? Yes, 4 exists. So let's increase it to 5. Now 5. Does 5 exist? Exist. So let's add here 1, so we get here 6. Here we get 6. And if we add 1 to this 5, we get here 6. Does 6 exist? Yes, 6 exists here. So let's increase it to 7. If we add 1 to 6, then we get 7. Does 7 exist? Yes, 7 exists. So let's increase it. Let's move forward. Let's add 1. So we get 8. Does 8 exist? Yet 8 does exist. Since 8 exists, what we're going to do, we're going to just increase this value to the next value. Then let's add 1. We get 9. Does 9 exist? No. Since we find out the element that does not exist, we checked from 0 to 8. All are exist, but 9 does not exist. So we'll break at 9, and we have the current streak. It means that we have a consecutive sequence of length 9. So we'll take the maximum of this length and 9. What is the maximum? 9. So length equals to 9. Now let's move forward. This is our next element. Does the previous element of 3 exist? That is 2. Yes, 2 exist, so just move forward. Does 6 exist? Yes. 1 exist. For 5, 4 exist. For 8, 7 exist. For 4, 3 exist. For 6, 5 exist. For 0, -1 does not exist. Now we're going to do the same process again. And we'll get the value 9. So max of 9 and 9 is 9. Let's move forward 1. And here we see the 0 exists. Let's move forward. We're just out of bound. We are done. So at the end, we'll return this 9. Here for the worst case, we already saw you that for once we might for iterations of our for every element we might have at most, for the worst case we will traverse n times. So the time complexity will not be of n times n. And here we have traversed twice. So actually it takes n plus 2n time complexity, which is equivalent to 3n, which is equivalent to 3n. So the time complexity takes 3n, and that's equivalent to constant and linear. So our time complexity is linear for these solutions. You might be worrying about how this is linear, but this is linear. This is not a quadratic time complexity. So this is how we can solve this problem. And this algorithm, I already mentioned that it will take a constant. So the time complexity, orbital time complexity is O of n, and the space complexity is O of n, because we're creating our set data structure. For the worst case, we will store in items on our set. So the space complexity is O of n. This is our algorithm. But one of the use cases of this algorithm is that I saw on LeetCode side, we don't have that use cases, so we can just ignore that. But in an interview settings, you should tell the use cases to recruiters or to interviewers. Otherwise, I don't know, they will be positive or negative. If they want that use cases, you should talk about in an interview settings. You should talk about the use cases. That's very, very important in an interview settings. So what are the use cases? We're subtracting from 0, so we get -1. And then when we get a value here that does not exist, we're just adding 1 to this value. Okay, that's great. Now here the problem is that if we have the minimum value we can store in integer. If we have here the minimum value, if this is the minimum value, let's assume the minimum value is a -infinity. If we subtract 1 from here, we'll go out of bound. We will cross the limit of integers. That's a problem, right? So if we have such a use cases, what we have to do, we have to check if we have a minimum value. We'll just start from that. We will not check the previous element. Okay, so if our current element equals to -infinity, or we're gonna check the previous, or if prev exists. Actually prev not exist. If prev does not exist, if this condition is true, then in this case we can just check it. And another use case is for the maximum integer in 32 bits or in an integer. So in an integer, maximum integer, let's assume positive. Let's assume that here we have a maximum integer infinity, and the previous of this maximum integer does not exist. So we'll start from here and we will add 1 to this. Whenever we added 1 to this, we will have overflow. We are out of the range of our 32-bit integers, so we will have a problem. So once we find out this maximum integer, we'll just stop. We will not add 1 to that. That is case. So this is the 2 use cases you should consider while solving this problem. Otherwise, you will fall in trouble. Anyway, this is our algorithms. So this algorithm will take of n time complexity, and the space complexity is of n. I hope you have understood this video explanations. If you have any question, you can post your question on the reply on the chat. I will answer your question, and let me check it. If there is any questions. Actually, there is some questions. All right, so all right, just wanted to stop by say thank you for making this, and topics or questions. Okay. Walaikum assalam. All right. So Muhammad Ilyas. Yes, I'll try to create a video on each topics playlist for a topic wise. Okay, I will try. I will try to create topic wise a video. Okay, you can. I will try to create a video on topic wise, and I plan to create it on first dynamic programming. I want to start first on dynamic programming, then I will try tree. So I was thinking this first. I will try to solve on dynamic programming graph. Then I will try to create a video on trees. Okay, so all right, recursion, DP, graph. Okay, great. Then I can trace. Thanks, Mohammed Ili. Thanks, Croesus. First, I'll create a video on recursion. Then I will move to DP and then graph and trace. Okay, I'll try to follow this. Okay, in the next live video, I'll try to create a video on recursion. Thanks, Croesus and Muhammad Ilyas for replaying here. All right, so I think I should move on. Now let's see the code for these solutions. All right, so let me set here everything else is to default. All right, now let's see the code for this algorithm. All right. I'll talk about the feature videos. First, let me solve these questions. Let me implement the algorithm. All right. First thing, what we have to do, we have to create a set data structure. Set will store integer. So integer set equals to new hash set. New hash set. And I'm going to just iterate the array. So int num in nums. I'm going to just iterate the array and I'm going to add all the element to our set. So set dot add num. So this loop will add all the element to this set data structure. Now what we have to do, we have to create our a variable len. Len equals to 0. In this len variable, we will keep track the maximum length or the longest consecutive sequence, the length of longest consecutive sequence. Now let's run a loop here. Int I equals to 0, I less than nums dot length. This is just a regular for loop. Right inside here, I'm gonna check does the previous element exist or not. Before that, I have to check that does our current element is the minimum element or not. So nums I, our current element, if our current element is equals to integer dot mean value. I don't have to check these edge cases here, but for this sake of this video, I'm just adding here. If our current element is the minimum element, we cannot check or we cannot subtract 1. And here I'm going to check if set dot contains. If set dot does not contains our num minus 1. So contains. Let's first get a current element. So current equals to nums I. And here I'm going to just change it to current. This is our current element, and here current minus 1. So if our set dot contains, if our set does not contains current minus 1 and our current is not the minimum value, this is for our edge cases. Inside here we have to check our current streak. our current streak equals to 1 and our current number equals to current. Now here we have to check while set dot contains current num plus 1, well our current num plus 1 while our current num plus 1 exists in our set, we will just increment our current streak and we'll increment our current num. So current num plus equals to 1. All right. So this is our while loop. When we're done with this while loop, we will have our current streak here and we'll take the maximum. So len equals to math.max of len and our current streak. All right. This is our core algorithm. And at the end, we will just return the len. This is the solutions. And here also you have to check the AS case. We might have the maximum element or integer.max value. If we have integer.max value, we will have here overflow, current num plus 1. So you have to check here first. Actually, for LeetCode test cases, we don't have to check it, but for interview purposes, we should concern these AS cases. So value. This is our algorithm. Now let's test it. Oh, I'm sorry, something wrong here. Set, let me check it, what's going wrong. If set dot contains, oh, it is, I'm sorry, what I'm checking here, I should check here if it's not equals to. If it not equals to, if it equals to, then we'll have problem. I think it should work, and it was just a silly mistakes. All right, accepted. Let's submit it. All right, we have solved this problem. This is the efficient solution of this problem. I hope you've understood this algorithm. If you guys have any questions related to this code and the explanations, you can ask on the replay forum. All right. So thanks, Dorisas. I will try to create in this order: first recursion, backtracking, DFS, and let me take a note from here. All right. So I'll for sure create video on recursion, then backtracking, DFS, DP, and graph. Just keep with this TechBuddy YouTube channel. You will find your content on recursion, backtracking, DFS, DP, graph, and trace for sure. All right, so if you guys have any questions related to this problem, longest consecutive sequence, you can ask anything about this video explanations on this chat forum. I'll be glad to answer. Okay, Croesus. I will create a video on recursion, backtracking, DFS, and DP, graph, and trace. All right, so thanks all of you for commenting and for joining this video. I'm just in this live video right now. Thank you very much.